let's try to solve another Leetcode problem. 1430. Check if a string is a valid sequence from root to leaves path in a binary tree. Yeah, so for this problem, we're gonna check the binary tree from the root node. So we're gonna check a path from the root to the leaves. So for example, we're gonna have 0, 1, 0, 1. So we can find this kind of path, so we're gonna return true. And for the second example, because the array is 0, 0, 1, but our path is 0, 0, 0, we don't have such kind of path, so we're gonna return a false. And similarly for here, the array is 0, 1, 1, and this is 0, 1, 1, but there's still a 0. So that means this is not a path. We cannot find such a path with 0, 1, 1 from the root node to the leaf. So we're gonna return a false. Yeah, it seems this problem can be solved by directly using the pre-order traversal of the binary tree. So we're gonna start from the root node and we're gonna check if we find a value. If it is equal, it is okay. We're gonna continue until we find the answer. So otherwise, if we didn't find it, so we're gonna go to the right side. And for here, if we didn't find it from the left side, we're gonna go to the right side until we find the answer. So if we traverse the tree and we didn't find the answer, so we're gonna return a false. So in this way, the type complexity is gonna be O(n). Yeah, because definitely we don't need to find all the paths, and then we're gonna check one by one. Definitely this doesn't work. Yeah, because if we find all the paths, it's gonna be n squared. And for each one of them, we're gonna compare with the array, and it's gonna times the length of the array. It's gonna be n cubic. Definitely it didn't work. Yeah, because let's say, oh, the array's length, maybe it worked, maybe it didn't, I'm not sure. And this is m, so n squared m. It didn't work. I believe it didn't work. So 5,000 squared times the array's length and the total node. Yeah, it is n squared times n. It is n cubic. Yeah, so it is times 5,000. Definitely it didn't work. Yeah, so this is why we're gonna use only O(n) to solve it. We just need to traverse the tree. Maybe we're gonna just use the pre-order traversal. So I'm gonna define a DFS with not inside. Yeah. So for my return, definitely I'm gonna return something. I'm go to the left side, and I also need index. Because I want to start from the first value from the node index 0, it means I'm gonna check the first node 0 with the root node. So this is why I'm gonna prepare an index. Before that, I needed to know the length of the array because I needed to control it. Otherwise, I don't know if this is a leaf node or not. Yeah, or sometimes if I traverse the tree, maybe there's another node. Maybe this is a 0 and this is a 1, and from 0 to 1 I get a path, but the length is only 2, but my array's length is 4. It means it is not the answer. Yeah, even I get a 0, 1, it is not the answer. I'm gonna return false. So this means I needed to know the length of the array. Yeah, so in between I need to have some check. Basically I want to return a true or false. But for the DFS recursive function, I need to go to the left side with I plus 1. The index is going to be updated. And or maybe left side I didn't find the answer, so I'm going to go to the right side. So I going to plus 1. Yeah, now from here, definitely I need to find some edge cases to return true or false. So let's first return the false. So if I is more than or equal to n, yeah. Definitely the array's length is 4, but if this index I is more than or equal to the length of the array, so we're gonna return a false. So if if the not exist, we're gonna return a false. Yeah. So if the not exist and not dot val not equal to array I. Yeah, if the value not equal, so I can return a false. I think that is all the false cases. Yeah, because if the index is more than or equal to n, it is a false. If the not exist, it's a false. If the value not equal to array value, it is a false. Yeah. Now I need to find in which case it's gonna be true. Yeah, and then I'm gonna start the recursive function for the DFS. So this means if I find a root node, so for example this one is a root node, so this one is a root node. If I find a root node, what I gonna do? So I'm gonna start from here. So if I find a root node, it means the not dot left not exist, and not dot right not exist, and not dot val equal to my current val. Yeah, so I'm gonna return a true. Yeah, so this means this is gonna be a leaf node, and my value equal to the current value. Yeah, and I also need to know the index I gonna be equal to n-1. Yeah, because I need to make sure that is the end of the array, and this value is just 1 compared to my leaf node, this one. I'm gonna return true. Yeah. So I think that is gonna be the solution for the problem, but let me just run it to have a check. So I'm gonna return DFS with the root node and 0. This is a typo. Let me just correct it. Yeah, as you can see it works. Now let me just submit it. As you can see it works, and it's pretty fast, and the time complexity is just ON, n is just 5000. Now let's optimize a little bit about the code. Yeah, because here, definitely from here, yeah, from here, if we didn't return a false, that means the node must exist. Yeah. So if the node exists, so we're gonna compare the node.value equal to array I. But here, if node.value not equal to array I, we're gonna return a false. Yeah. So this means if we didn't return a false, definitely the node.value should equal to array I. So we don't need to compare here. Yeah. Yeah, because definitely it is a true, so we don't need to do that. Let me just run it to double check. As you can see, it should work. Yeah, although it didn't improve speed, but it doesn't matter. You should know we actually improved the code. Maybe we just needed to write it in one line. Yeah, so if I more than or equal to 0, here we're gonna use the boolean or not node, or not.value not equal to array I. So we're gonna return a false. Yeah, and then this is the false case, and then we're gonna use another if to check it's gonna be true. So here we have to check it is a leaf node, and here we have to check that I gonna be equal to n-1. Or we can use the elif. It is okay. Yeah, because if it is not a false, definitely it is gonna be a true. Yeah, now let me just submit it. As you can see, it also works, and I think this is the concise way to write the code. Thank you for watching. See you next time.